Hi, good day. Today we will discuss on recursion in computer programming. We will take a brief look at a phrase. Before we go into the subject, we'll take a brief look on about this phrase on intrinsic beauty. It is from Shakespeare's Romeo and Juliet. It says, "A rose by any other name would smell as sweet." So, this is a very interesting phrase which talks about the importance of intrinsic beauty rather than externally how things look. Okay, we will now go into the topic of recursion. Now, here, what we have is recursion. Now, what is recursion? Here, we will use if anything uses itself to define itself, then it is coming under the purview of recursion. So here in computer science, we have a function which calls itself. Then that's recursion. Now here is an example here demonstration. We have an integer function r. This is the name of the function. These are the parameters. This is the body of the function. So what we have is this is the body of the function. Within the function, we have the function within the body of the function. Y is equal to function r. So it is calling itself. How does it evaluate? It calls itself to evaluate. So that's recursion. So we will take one example here. Example main looks like a C program. So here we have main program and result is equal to factorial I. So here we are calling a function called factorial. Now what does the body of the factorial function contain? It contains like this factorial from main, something like a C program. We have factorial being called from the main program, and in the definition of the function factorial is the integer parameter. We are evaluating and then return n into factorial of n minus 1. So that's how we are evaluating the factorial. We will take a detail with the same thing we will look into in more detail. Now here we have what is the definition of factorial? 1 into 2 into 3 into 4. That's factorial 4. So what is factorial n? N is n into factorial of up to previous number into factorial of n minus 1. So this is a recursive definition of factorial. We will see more such what are called recurrence relations when we come into dynamic programming in design and analysis of algorithms later on in a future date. So this is a recursive definition here. Now this is very interesting here. Factorial 5 is equal to 5 into factorial 4. So this mathematical equation, we have written it like this. Now it is interesting to note that the left hand side contains what we are trying to achieve, left hand side, whereas the right hand side says how to achieve that. Okay, we will come to that. Before that, let's trace what happens here. Factorial 5 is 5 into factorial 4. What's factorial 4? 4 into factorial 3. What is factorial 3? 3 into factorial 2. Factorial 2, 2 into factorial 1. Now, factorial 1, we are not going down again. 1 into factorial 0, 0, 0 into minus 1. We are not going down anymore. We have to stop it here. So, factorial 1, we know, trivial, it is 1. We know that much. So, 2 into 1. So, 1 factorial is 1. So, 1 is returned here. 2 into 1, 2. 2 into 3, 6. 6 is written here. 6 into 4, 24. 24 into 5, 120. So red indicates the return path. So this is how the entire tree is traced. Now we will look into the actual program, how it looks. Now here we can see this is a program on recursion. The same example, factorial n is equal to n into factorial n minus 1. So it's a main program. Integer, we are calculating factorial for I is equal to 5. Result initialized to 0. Integer result is equal to 0. Result is equal to factorial of I. Actually, this is a comma here. Okay, integer I is equal to 5, result is equal to 0. Result is equal to factorial 5. And after that, we are saying print I and result both. Now, here we are calling factorial I. So, what's factorial I? Factorial I is one statement basically, n into, we are doing this evaluation here, n into factorial n minus 1. We are doing n into factorial n minus 1. So that is what we are evaluating here. So this one thing is shown in the return statement here. So return n into factorial n minus 1. Okay, so this one statement is good enough. Now there is something called, we have to set up what is called base case or termination, because it cannot go in an endless loop. So we have to terminate it somewhere. So the base condition, if n equals 1, we say return 1. So that's what we are saying. If n is less than or equal to 1, return 1. Otherwise, return n into call itself using n minus 1. So that's how the factorial recursion is defined, and factorial we have achieved. Thank you very much, and have a great day. Thank you. Bye.